In this video, I'm going to show you a very useful online graphing calculator tool. So for those of you who don't have a graphing calculator, and you might need it for Algebra 2, Precalculus, or even Calculus, here's something that you can use. Go to Google and type in online graphing calculator. The first link that shows up, the Desmos graphing calculator, select that link. And it's very useful. Let's say if you want to graph a function. You can graph quadratic functions. You can easily see where the x-intercepts are, -6, +1. You can graph cubic functions. Even absolute value functions. So almost anything that you need. We can try a square root function. And what's useful is you can also graph polar equations. Let's say if we want to graph r equals 2 cosine theta, you can graph that. For those of you who have to graph polar equations like Limacons, Leibniz gates, this tool is very, very useful. Let's see what else we could try. Here's another polar equation, 3 sine 5 theta. So as you can see, it's very useful. Now let's try trigonometry. Let's try some trigonometric equations. That's 2 sine x. Here's -3 cosine x. You can also graph secant, cosecant, and even tangent. We can also graph logarithmic equations and a lot of other stuff too. Let's try inverse sine. And then there's arc cosine. Okay, that didn't work. Let's go back to functions. There's arc cosine. Let's try a log equation, but with a different base. It's log base 3, let's say x minus 4 plus 2. So as you can see, you can graph almost any function that you need. That's the absolute value function, which you could find pressing that button too. Let's see what else we could do. Sometimes you may need to graph multiple functions. Let's say if you want to solve a system of equations by graphing. This is 2x minus 5, and then you can hit enter and write in another equation. Let's say we want to graph 7 minus 3x. So at the point of intersection, that's the solution to the two equations. Let's try something else. 2x minus 3y equals 6. So sometimes it doesn't have to be y equals. You could just write the whole formula. And let's say 3x plus 4y equals 12. So the solution is here. So that's how you could solve system of equations by graphing. You can type the equation in and simply find the point of intersection. So for those of you who are taking calculus, and let's say if you need to find the x-intercepts of a graph. For example, let's say you have x squared minus 4x, and you want to set it equal to 0. The intercepts are 0 and 4 in this example. So therefore, if you set x squared minus 4x equal to 0, your answer is x is equal to 0 and x is equal to 4. So that's how you can solve equations by the use of a graph. Another example is factoring. Let's say if you want to factor x squared plus 5x plus 6. Now, two numbers that multiply to 6 but add to 5 are 2 and 3. But when you solve it, you can have x plus 2 equals 0, x plus 3 equals 0. So x is going to equal negative 2 and negative 3. But you can reverse factor it if you simply just graph it. As you can see, the intercepts are negative 2 and negative 3. So those are the solutions. If x equals negative 2 and x equals negative 3, you know the factored form had to be x plus 2 and x plus 3. You got to change the sign. So if you're having difficulty factoring an equation, you can graph it and find the x-intercepts. So that's another useful technique that might be useful to you in algebra. Now sometimes you may need to graph rational functions, and you got to find the horizontal and vertical asymptotes. But you can graph it here. Here we can see that the vertical asymptote is at x equals 2. If we add 3, the horizontal asymptote is plus 3. So any type of rational function that you need to graph, this is a very useful tool. Here's another one that has a vertical asymptote at x equals negative 3 and a horizontal asymptote at 1. Now it doesn't end there. You can also graph vertical lines. Let's say x equals 2, that's a vertical line at x equals 2. And horizontal lines like y equals 3. You can also graph inequalities. Let's say x is greater than 2. So you got a vertical line at 2 is a dotted line, but you shade towards the right because x is greater than 2. Or you could say that x is equal to and greater than 3. So you have a solid line shaded to the right. Or let's say that y is less than or equal to negative 1. Or you can have a function. Let's say y is less than 3x minus 5. Or you can have a system of equations, and let's say y at the same time is greater than 2x plus 3. Let's say y is less than negative 2x plus 8, and y is greater than 3x minus 5. So sometimes you may need to find a region in which both graphs are shaded, which is here. Now there's so much more you can do with this tool. You can also graph exponential functions. Let's say like 2 raised to the x. If we add a plus 3, then the horizontal asymptote is 3. We can also graph e raised to the x or ln x. A lot of things we can do, but we can do more than just graphing. We can also perform calculations. For example, 4 times 3, that's 12. Or let's say 8 plus 5, 13. Or 126 minus 39, 87. You can also convert a fraction into a decimal. Let's say 3 over 4, that's 0.75. I wonder how to convert a decimal back to a fraction. I don't think we could do that. But you can convert any fraction into a decimal, which is basically simple division. Now, there's a lot of other stuff that we can do. We can also get rid of this keyboard. We can hide it. We can zoom into the graph. You can zoom out if you need to. And There's a lot of other calculations that we can do. For example, let's say if we wish to evaluate a log. Let's say log of 2, base 2 of 8. It's 3. 2 to the third power is 8. So let's say if we want to figure out log of 4, 64. That's going to be 3. So you can evaluate logs with this tool. And there's other things that you can do. For those of you who are taking calculus, you can also find the value of an integral. Let's say if you want to integrate x squared from 1 to 2. The value is 2.33. So that's another useful tool if you need to find the area of a shaded region or something. And there's more. For those of you who are taking statistics, you can go to stats. And let's say if you want to find the average of a few numbers. Let's say the average of 7, 9, and 11. That's 9. If we change it to 13, it increases to 9.67. So you could find the average or arithmetic mean of a bunch of numbers. Let's see what else we can do. Standard deviation. Standard deviation could take a long time to calculate. It's a huge formula, but this tool makes it easy. So let's say if we want to find the standard deviation of 3, 4, 6, 7, and 8 is 2.0736. So if you need a quick way to find it, you could just type it in. We also have combinations and permutations. For example, 5p3, you can write it as 5 comma 3, that's equal to 60. And then we have factorials. 5 factorial, which is 5 times 4 times 3 times 2 times 1, that's 120. Next up, for those of you who are learning arithmetic sequences, when you need to find the sum of an arithmetic sequence or something else, you can use this. Let's say you need to evaluate an expression in sigma notation. Let's say from 1 to 5, n squared. It has to be in terms of n, not x, for this to work. So what this really means is that you're adding 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and you're stopping at 5. The sum of those numbers is 55. So that's how you can use sigma notation with this graphing tool. And let's focus on evaluating trig functions. So sine 45. It looks like this is in radian mode, so we can convert it to degrees. Sine 45, which is root 2 over 2, in its decimal form, that's 0.707. Sine 30 is 1/2. Sine 60, 0.866. Now let's convert it to radian mode. Sine pi over 3, which is sine 60. Sine pi over 3 is root 3 over 2, or 0.866. Sine pi over 6, which is like sine 30, that's 1/2. So that's how you can evaluate trigonometric functions at different angles. So that's my 2 cents for today. Thanks for watching, and I hope this tool benefits you in your math courses.